In this lesson, we're going to learn about the distributive property, and we're also going to be putting that together with a topic called combining like terms. So you may have heard of this concept or property in years past, but I would like to review it with you, and I do want to expand your understanding on it this year. So here's what the distributive property looks like. Basically, what you're going to be doing is taking a number or a variable on the outside of a set of parentheses, and you're going to be distributing or giving that variable to each of the other pieces that are inside the parentheses. So if we look at this first example here, the 3 is the number that's being distributed, and he's going to be distributed to the x and to the 8. So the operation that you use with the distributive property is multiplication. It's the only one that you're going to use. So when I distribute, I'm going to use these little lines to kind of show you, but you do not need to use these lines when distributing. But I'm going to multiply 3 times x. And 3 times x is going to leave me with a term 3x. Then I'm going to distribute 3 into the second piece. Now the second piece, I need to be very careful. I need to include that operation in front. So really it's 3 times positive 8, which is going to give me positive 24. So I'm going to tack on positive 24 to give me the expression 3x plus 24. So this is called distributing, and that is the final answer after I've distributed. All right, you can also see that it creates an expression. So I can't go from an expression to an equation. I can't just add an equal sign out of nowhere. So if you start with an expression, you're going to end with an expression. All right, in the next one, the number that I'm distributing is a 2. So I'm going to distribute it into 3x. So 2 times 3x is going to leave me with 6x. Then I'm going to distribute 2 into the negative 4. You have to be real careful with the negative in front. 2 times negative 4 is going to leave me with negative 8, leaving me with the expression 6x minus 8. All right, let's go ahead and just bump it up slightly. I'm going to be distributing negative 4, but this time I'm going to distribute it into 3 terms instead of 2. So negative 4 times 2a is going to leave me with negative 8a. Negative 4 distributed into the second term is negative 3b. So a negative times negative is going to give me a positive 12b. And then the last one, negative 4 is going to be distributed into positive 6, leaving me with negative 24. And that is my final answer. All right, the last one here is I'm going to introduce you to Harold. Harold, he always shows up in the worst situations. Harold is when you have that negative outside of a parenthesis. Really what Harold is, he's a negative 1. But we don't really write the 1 there. We kind of assume that it's a negative 1. So if you like, you can go ahead and you can slip a negative 1 right in front of that symbol, but you don't have to. You just need to know that Harold is negative 1. So I'm going to distribute Harold into negative x. So negative 1 times negative x is going to leave me with positive x. Negative 1 times positive y is going to leave me with negative y. And negative 1 times negative 4 is going to leave me with positive 4. And that is how you distribute Harold. I know that's a silly name, but sometimes it's easy to reference if we have a funny name attached to it. Okay, now we're going to learn how to use this concept in these big algebraic problems. So they look kind of ugly now, don't they? But I really just want you to use the knowledge that you have of multiplication and rational numbers, and we're just going to kind of piece this all together. So the number that's being distributed in the first one is negative 18. I'm going to distribute him into 1/3 x. So really all I'm doing here is saying negative 18 times 1/3. Well, I could do that in my calculator, but I don't really think we need to, because negative 18, if I were to just kind of pop him over a 1, I could just multiply straight across, right? And it's really saying negative 18 divided by 3, and that's going to give me negative 6x. Then I'm going to take negative 18 and I'm going to multiply it by positive 1/9. Do that same concept. It's really saying negative 18 divided by 9, which is going to be negative 2. So that big ugly problem just turns into negative 6x minus 2, and that's your final expression. Now in this second example, you can see that there are two places where you have to distribute. So they're going to be two separate problems. So I'm just going to focus on the first problem. So I'm just going to draw a little dotted line here, and this is going to separate my problems. So let's just do the first half on the left. I'm going to distribute negative 5 into negative 2/5 y. Now, just take a look at this. I'm multiplying a negative times a negative. So isn't my answer going to be a positive number? So really, I can just kind of cross those negatives off so they don't confuse me. Now, 5 is really saying 5 over 1. So I'm looking at 5 over 1 times 2/5. Well, isn't that going to be 10 over 5, right? Which is going to simplify to 2. So this is going to be 2y. All I did there was some operations with some rational numbers. That's all. And we studied that earlier in the unit. Okay, now I'm going to do the second part of the problem. Now, the negative here. The negative is either a negative or it's a minus sign, but you have to pick one. If you want it to be a minus sign, then you need to put the minus sign in place. But I'm going to use it as a negative, just so we don't spend any time confusing anyone. I'm going to distribute negative 4 into 6/8 x. So we can see that negative 4 times 6 is negative 24. And I'm going to divide that by 3. And that's going to give me negative 3x. Then I'm going to multiply negative 4 times that whole chunk there, negative 3/4 m. Now negative times a negative is going to give me a positive. And I really have 4 times 3 is 12. Divided by 4 is going to give me 3. With an m there, of course. And I'm done. So it really wasn't anything different than we were doing before. We just have to work with those rational numbers. All right, now that we know how to distribute, I want to teach you one more concept. This is a little bit easier. This is called combining like terms. Like terms have the same variables and the same exponents. So we want to simplify these and really kind of condense them or consolidate them. So in this first example, you can see that like terms are literally terms that have the same last name. Meaning, you can see in this example, I'm going to go ahead and circle my like terms, 6x and positive 2x. Those are like terms. They have the same last name, x. Now, if I had an x and an x squared, they are not the same last name, so I can't combine them. But since these are the same, I'm going to go ahead and put them together. I'm going to use that operation in front of the 2x to simplify it. So it's really saying 6x plus 2x is going to leave me with 8x. Now, I can go ahead and I can grab another pen color if I like, and I'm going to go ahead and circle other like terms. So I have positive 5y. And I have negative 3y. The y's have the same last name. So I'm just going to go ahead and combine them using the operations in front. So I have positive 5 minus 3. That's going to leave me with a positive 2y. So what I did there was I combined all the terms that were alike to give me 8x plus 2y. All right, let's add an example with some powers here. So let's go ahead and find some like terms. I'm going to go ahead and find these like terms first. I have an x, and then I have a positive 3x. Do you see how the x and the x are the same? It's not the same as x squared. So I'm going to go ahead and combine them. X plus 3x is going to leave me with 4x. And then I'm going to go ahead and find two other terms that are alike. I have negative x squared and negative 4x squared. Just because the two terms are negative doesn't make them like terms. What makes them like terms is the last name, x squared. So negative x squared, remember this is kind of like a Herald concept. This is negative 1. So it's negative 1x squared minus 4x squared is going to leave me with negative 5x squared. And you can see that I'm left with one more piece here. And you can see that he actually has nobody to combine with. This is called a constant. A constant is a number that stands alone by itself. It doesn't have a variable attached to it. With the constants, we usually just like to tack them on to the very end. They usually don't have anybody to combine with. And that's my final answer. So that's how you combine like terms. So we need to know how to do that because now we're going to put distributing and combining like terms, we're going to put it all together. All right, so let's go ahead and look at the first example. Now, the key to know here is that you always distribute before you combine like terms. It always happens first. So I put that little note up here to help remind you. So let's go ahead and distribute. In this first example, do you notice how the number that's standing in front of the parentheses is negative 3? That is the number that I'm going to distribute. The 9w has nothing to do with what's being distributed. So I'll deal with him later. And actually, I'm just going to rewrite him. I'm just going to kind of bring him down. We don't need him right now. I'm going to distribute negative 3 into 2w. So negative 3 times 2w is going to leave me with negative 6w. And then distribute negative 3 into 4. That's going to leave me with negative 12. Now, distributing is done at this point. Now I want to combine like terms. So you can see here that I do have two terms that are alike. I have 9w and I have negative 6w. If I combine them, they're going to leave me with 3w. But what about this guy? What do I do with him? I'm just going to bring him down because he's still a part of the problem. I can't just eliminate him. He has to be there. And I'm done. All right, let's take a look at this next example. This time I have two areas where I need to distribute, just like on the last slide. So I'm just going to go ahead and start with the first portion here. I'm going to distribute 8 into x. So 8 times x is going to leave me with 8x. 8 times negative 5 is going to leave me with negative 40. Don't forget that operation in front. Now, that's the first portion of my distributing. Now I have like a whole new problem to work with. Now, unlike before, I have to distribute the negative 4 into the y and the 10. So negative 4 times y is going to leave me with negative 4y. Negative 4 times 10 is going to leave me with negative 40. Now, I do have this guy here just kind of hanging out on the end. I'm just going to bring him down. He's still a part of the problem. He's just not being distributed. Notice how I didn't take that negative 4 up top and distribute him into negative 2x. That would not have worked. He's not inside the parentheses. All right, now let's go ahead and combine like terms. I'm going to go ahead and you just pick like terms that you see. And it looks like I have 8x and it looks like I have negative 2x. So I'm going to go ahead and combine them to give me 6x. It does not matter the order of the variables right now. We will discuss the order of the variables later on when we talk about polynomials. All right, so I also have, oh, look at this. I have two constants that are like terms. They're both, they both happen to be the same. Now, they're not like terms because they're both negative 40. They're just like terms because they don't have a variable attached. So negative 40 minus 40 is going to give me negative 80. And then the last piece of this, you can see here, all I have left, I'm trying to pick a different color, is negative 4y. So I'm just going to go ahead and tack him onto the end. And you are all done. You've not only distributed, but you've combined like terms. All right, I have one more problem for you, and it's my favorite one because it has a really cool concept within it. And it's this fraction that you see here. So let's go ahead and deal with this fraction. You can see that this problem doesn't have any distributing. And I know that because there aren't any parentheses. So distributing, done. All I need to do is combine like terms. But what do I do with this fraction thing? when I have a situation where I have a numerator that has 2 or 3 or 4 terms and a denominator that just has 1 term, here's what I do. I do this little thing where I like to call it the heart or the butterfly, whatever you really like. The butterfly comes in like this. Doesn't look like a little butterfly. Where I'm actually going to do 2 separate problems here. So I'm going to take 14x, actually positive 14x divided by 7, and that's going to leave me with 2x. And then negative 21 divided by 7 is going to leave me with negative 3. And I took care of the little butterfly. But what do I do with this stuff? Just like before, bring it on down. So I have 5x plus 6, and that 2x is positive, so I need to make sure my operation is there. So as you can see, I didn't distribute, but I did do that little butterfly thing. It doesn't really have a special name. I just like to call it the butterfly. All right, now we're going to go ahead and combine like terms. So I have my 5x and I have my positive 2x to give me 7x. And if I go grab a different color, I have my 2 constants that are here. 6 minus 3 is going to give me plus 3. So this whole big expression that I started with is just going to simplify down to 7x plus 3. All right, so that was a little lesson on the distributive property and combining like terms, and I did add this little butterfly technique just to kind of show you this in case you encounter it in some of the problems that you're working.